Object variables provide a convenient way to manipulate objects in VBA. The process of assigning an object to an object variable is called binding. There are two ways in which an object can be bound: early binding and late binding. Understanding these concepts is especially important when trying to access applications beyond Excel and VBA and when distributing the final macro to the end users. If we declare an object variable as a specific object type, then we're using early binding. In the first example, we declare the variable as a worksheet, then as a dictionary, and another one as a PowerPoint application. In each of these three examples, we are creating an object variable via early binding. The point to highlight here is regardless of how the object variable is assigned in the set statement, as long as the specific object type is used in the declaration, it's early binding. If we declare an object variable as a generic object type, then we're using late binding. On the right hand side, we can see three examples of late binding. Each group of code on the right is equivalent to the code on the left. There are two main differences that we can notice within the code on both sides. In late binding, we declare each variable as an object, and we have to use the create object function to create a new object and assign it to the object variable. Let's take an example where we can write VBA code from within Excel to access the PowerPoint application to create a PowerPoint presentation. This is possible because of OLE automation, now known simply as automation. Automation makes it possible for an application to expose its objects and for another application to manipulate those objects. This reusability of objects is achieved using a standard called the Component Object Model, or COM. Information about those objects is available within a type library, which we can access by going into Tools and References. Let's check that out. Let's search for the Microsoft PowerPoint Object Library. If we set a reference to this library, by ticking the checkbox, we get access to all the properties and methods of the objects exposed by the PowerPoint application. Now, in order to access PowerPoint through an object variable, we can directly use the specific object type, which is the application object in the PowerPoint library. Let's do that. Let's create a sub. Declare an object variable. We will declare it as a specific PowerPoint object type, and to do that, we need to mention the library name, which is PowerPoint. And notice we get access to IntelliSense to the PowerPoint object library, which is available to us only because we have set a reference to it. And the specific object that we are after is the application object, which is the top level object in the PowerPoint object hierarchy. And this is early binding. Now, we can go ahead and create a new instance of the application using the new keyword and assign its reference to our object variable. Use the keyword set to assign a reference to our object variable and the new keyword to create a new instance. And this code out here should open up PowerPoint for us. To make the application visible to us, we can set the visible property to true. Let's run our code. And the PowerPoint application opens, although there's nothing in it. And alternatively, we can create the PowerPoint application object directly without the need for setting a reference. So let's go ahead and untick the reference. Untick, okay. Let's comment out our early binding code. Now we need to declare the variable as the type object. And to create a new instance of the PowerPoint application, we can use the create object function. The create object function takes an argument, which is the class name of the object that we want to create, which is the PowerPoint application object, and we need to pass it in as a string, which means wrap it inside double quotes. And just to clarify, this class name consists of the application name, which is PowerPoint, and the object type, which is application. And in fact, we have to use the create object function to create the root or parent object while using late binding. But any derived objects such as a PowerPoint presentation can be created using method calls on this initial bound object. So for example, if you want to create a PowerPoint presentation, we would need to declare another object variable as the object type. and use the presentations.add method on this initial application object. Dot, and notice we don't have access to IntelliSense anymore. That is, now we need to manually type out the methods and properties for any object within the PowerPoint object library. So let's type out the collection presentations and call the add method. And just to clarify once again, this add method will create a new presentation within the instance of the PowerPoint application that we have created or initiated up here. Okay, let's run our code. The PowerPoint application opens and we can see a new presentation. Presentation 1 has been created, although it has no slides in it. And let's leave our PowerPoint application open for now. So I will just minimize this. If we already have an instance of an application running, we can use the getObject function instead of createObject. Let's do that. The first argument is the path name, which we can leave blank. And the second argument is the class name, which is the same as what we have in the createObject function. Okay, let's run our code. Remember that we already have PowerPoint open. And we can see below that a new presentation, presentation 2, has been created. Now, if you don't have an instance already open, the getObject function will throw an error. Let's try that out, run the macro, and we get a runtime error. So, we could use the createObject function regardless of whether an instance of the application is running or not. But just remember to quit the application once you're done with your code unless you specifically want that application to stay open. We could run this code, but there's no real point. It would just open PowerPoint, create a blank presentation, and then close PowerPoint, discarding that presentation. But let's just run it once just to make sure that there are no errors. And that ran okay. Compile time is the time between clicking start on our macro and prior to the execution of any code. And by code, we mean any line in our macro besides any comments or declaration statements, which basically leaves us the executable statements. One of the many tasks that VBA performs during this time is evaluate all the object references within our code. So that means checking the specific object types in our declaration statements and references to object methods and properties in the rest of our code. When we set a reference to the object type library, VBA is able to evaluate all the object references within our code during compile time. This is what happens in early binding. And if we don't set a reference to the object library, VBA will not have any knowledge of what an object is supposed to be during compile time. So VBA will move on to executing our code statements, which happens during runtime. And when it encounters the createObject function, it will do some lookups in the background to determine what this type of object is and return its reference back to us. Which means in late binding, the resolution of object references happens during runtime. But how does this affect us? Firstly, Microsoft documentation claims that early binding is faster since it doesn't have to perform any extra lookups such as during runtime. But frankly, the difference in speed between early and late binding is negligible. Secondly, early binding is better at spotting mistakes in our code. For example, if we have made a mistake, say naming a method, VBA will spot it at compile time. Let's check out an example. This addTest method is incorrect. And notice there is a debug.print statement prior to the incorrect method. Let's run the code and we get a compile time error. Okay, but what's relevant here is that we cache the mistake prior to executing any line of code. So for example, this debug.print statement never got executed even though it's situated before the addTest method. Now let's look at the late binding variant of the same code. And note that no reference has been set to the object library. We have the same incorrect addTest method. Let's run our code. We now get a runtime error. But notice the debug.print statement was executed, which means that VBA will run all the statements prior to our mistake being spotted. Hence, it's better to catch these reference errors during compile time. And this is useful when we are building and testing out our code. So building out our code with early binding is recommended, but we can always update the code to late binding prior to deploying or distributing our final version. Next, we'll discuss the whys and hows of converting our code to late binding. So why use late binding? The main argument for using late binding is to avoid compatibility issues. So this is our early binding code. Let's look at the reference to the PowerPoint object library. We have selected version 16.0. Now, let's assume that our final macro is going to be used by multiple end users. For our macro to run on their computers, they need to have the exact same version of PowerPoint library available on their computer as well. If it's a prior or newer version, there is no guarantee that a macro will work for the user. They will most likely get a compile time error, and we don't want that. The create object method via late binding doesn't rely on any type library references. Hence, it will allow our macro to work on the end user's computer as long as the application that we are referencing is installed on their machine as well. There are some more nuances to consider when dealing with non-Microsoft Office applications, but we'll keep this conversation on the high level. So, our recommendation would be to use early binding when building a macro, mainly due to the benefit of the IntelliSense feature, and we could use late binding when distributing a macro, mainly to avoid any compatibility issue. And now, the question is, how would we convert our code from early to late binding? Let's check that out next. In this section, we'll look at how to convert code from early binding to late binding. There is a simple chart here in Excel in a sheet named Sales. It shows the revenue for 4 regions. The chart has been renamed to Revenue Chart in the name box. And we are going to copy this chart over to a PowerPoint slide. We will build the initial application using early binding, and later we will convert our code to late binding. I have already set a reference to the PowerPoint object library. Let's quickly build out the initial part which we have already seen before. First, we'll create an object variable to refer to the PowerPoint application object. IntelliSense simply provides a much better coding experience. Let's continue on, and we'll create an object variable to refer to the PowerPoint presentation object. And now let's create an object variable to refer to the PowerPoint slide object, which is the rough equivalent of a worksheet in Excel. The add method will take 2 arguments. First is the index number or the position of the slide, which is 1. And then is the layout. And notice we get a list of available options for us via IntelliSense. Let's select the blank layout. Next, let's copy the chart. We need to follow the Excel object hierarchy for shapes to identify the chart and then call the copy method. Now, we need to paste this chart into a PowerPoint slide. We will paste it as a picture, and we will select the data type as the enhanced meta file, which is just a high resolution picture. Let's save the PowerPoint file. I'll save it on my computer by providing the full folder path and the file name that we want to save it as. Close the presentation and quit the PowerPoint application. That's our code. Let's run it. Let's quickly check out the file in the save location. That's a file. Let's open it. Looks good. Okay, time to convert this code into late binding. First, we'll do this exercise step by step, and then we'll go and check out a trick to help us avoid any confusion. Step 1 of converting our code to late binding is to remove the reference to the type library. So Tools, References, untick the reference, click OK. Step 2 is to remove every specific object type related to the PowerPoint application and replace it with the type object. We have declared 3 specific PowerPoint object types, which is the application, presentation, and slide. Let's replace each one of them with the type object. Step 3 would be to use the create object function. Now, we can't use this new keyword to create any new PowerPoint object. This only works when the object after the new keyword is available in our type library references. In our case, it isn't. We need to replace this assignment with the create object function. And we don't need to change any of our other assignments because these objects are derived from the application object which we have already created up here. And step 4 would be to replace any named constants, so these two right here, with the underlying value of those constants. Late-bound objects don't recognize name constants. So let's look at this line of code, come to our constant. We need to supply the value for the constant pp layout blank. We can get the value in several ways. We can search online. Microsoft Learn will definitely have what we're looking for, but it may take a few steps to get there. Alternatively, we can check for the value in the object browser. So let's copy our constant name, and we do need to temporarily select the reference for the PowerPoint object library. Let's do that. Go to the object browser, click on the icon out here or F2. Search for the value pp layout blank in this second drop down bar. We could even filter our search to the results in the PowerPoint library. Hit the search button given by the binoculars icon and we get a search result. If it's not selected, select it and we can see the value of the constant below, which is 12. Great. Let's replace the constant in our code with this value. And I would suggest to put a comment telling us what this value represents for our reference later. And there is one more line of code to fix. But before we do that, let's remove the object reference and see what happens if we try to run this code. Remember, we are now in late bound mode. Run the macro. We get a compile error saying that a variable is not defined. And more importantly, the undefined variable is highlighted for us. If there is an undefined element within our code, then running the macro will take us to the first undefined element. There might be others, so we need to fix this element and run the macro again to check for other compile time errors. And if our macro consists of hundreds of lines of code, the compile time error messages would be handy in making sure that we have not missed out fixing any references just like we have out here. However, it may not be practical to run a full macro just to find compile errors. We may be performing tasks such as updating a database within our code. In that case, we may want a safer way to catch compile time errors. To do that, we can go to Debug and Compile VBA project. Clicking on this menu option will perform the same compile time checks on our code as we would see when running the macro in the usual way. However, the big difference is that our code will not execute. So we can use this option to check whether our code is syntactically correct. Let's check it. And we get the same message as before. Okay, now let's fix the last line of our code. Same as before, we need to provide the underlying value for this constant. We could go to the object browser to find the value. However, we can try another way by simply printing out the value within the immediate window. We still need to turn on the reference to PowerPoint back on just for a bit. Come to the immediate window. To print the value of a property or a constant, use the question mark followed by the constant name. Press enter and we can see the value printed below, which is 2. And let's leave the original constant name within a comment. And that's it. Let's remove the type reference. Our code is completely late bound now. Let's run the macro. And it plays out successfully without any runtime errors. Early binding is when we declare objects using a specific object type. Late binding is when we declare objects using a generic object type. Let's go through the differences in using early binding versus using late binding, which we have covered within this lesson. With early binding, we get access to IntelliSense. In late binding, we don't. With early binding, we do need to set a reference to the type library of the parent application. Late binding doesn't rely on any type references. Early binding is faster, but late binding is marginally slower, if at all. In early binding, we need to make sure that the end user of the macro has a compatible version of the application's object library. There is no such requirement in late binding since we don't set any type reference. Our recommendation is to use early binding when building our code and to use late binding when deploying or distributing a final macro. We can use name constants in early binding, but we need to use the underlying values of those constants in late binding. In these past 3 lessons, we have covered different flavors of variables. Data variables, which use values such as numbers and text, constants whose values won't change once assigned, object variables, which refer to objects. In the next lesson, we will deep dive into how to effectively use data types.